Hello everyone, welcome back to part 2 of rounding off, where this time we'll be rounding off decimals. In the last video you saw that we rounded off integer numbers, and now this time I've made a little change. That is, I have added a Google Drive link of all the class notes that I will be covering, and they will be uploaded in PDF form. So if you need to refer, you can just go ahead and check the link in the description box. And if you're an Apple user, then I have the OneDrive link up as usual. So yeah, this is part 2. Let's learn how to round off decimals. So let's learn how to round off decimals. First of all, we'll be seeing how to round off two decimal places, which is equivalent to nearest 100. Let's take a few examples and learn how to do that. Okay, here are a few examples. And by the way guys, I'm using Notability because it's easier to make a PDF out of this thing than as compared to OneNote. So I will be using Notability from now on. Okay, let's take a few examples. I am taking the first example as, let's say, 7.253. okay, this is the first example. We'll have to round it, we'll have to round off it to the nearest 100th. What you're gonna do here is just consider this part, that is 253, and round it off to the nearest 100. How do we do that? We take these two numbers, make a floor and make a seal. And where does it go? 53 goes into seal. So it is roughly, you can say, 53 becomes 300. So after rounding off, we get 7.300. We don't need to write 00, so we can simply write it as 7.3. Okay. Then like the same thing we can do again for a different example. Let's say 6.747. How do we do that? So we take 747, the decimal part, the part of the point. We take the two numbers, that is 800 and 700. Where does it go? 47 goes here, so we have 6.700, which we can also write as 6.7. okay, this is one type. The other type is this time we'll be making it somewhat like this. Here we are completely eliminating anything that is after the one digit, after the first decimal point, as you can see here. Are you seeing? As you can see, well, let me just change the color. In the question it was given 6.747 and the answer we get is 6.7. So there's nothing after the first point mark, nothing after this. This part is completely empty. Okay, what we will do now is how to round it off to the nearest 10th. Okay, it is somewhat like if we have an example of 8.252. okay, we'll have to round it off to the nearest 10th. okay, what do we do here? See, we'll take these numbers. Okay, we'll take the numbers after the decimal point, that is 252. Nearest 10th, you guys know what the rule is. We take the last digit, convert it to 0 on both sides, and this is the first part. Let me just use a different pen. The first part is 25, so we do write it as 25 here, and 25 plus 1 is 26. So we have the two sides. Where does it go? It's 2 as the last digit, so it goes towards the left, and we have 25, and so we can write the decimal as 8.25 as the answer. This is known as, this is what we do as we know as, okay, let me just clarify. This part is, wait, let me just write it here, rounding off one decimal point. One decimal point. How so? We have 8.252. There's 3 decimal points here, as you can see. And see the answer. Oh, what is it? Okay, no. See the answer. We have 8.25. So we managed to remove one decimal point that was somewhere over here and convert 8.252 to 8.25. This is called rounding of one decimal point. Okay, I'll take another example. Let's say 7.972. We'll do both. Rounding of two decimal points and one decimal point means converting it to a one decimal pointer and converting it to a two decimal pointer. Anyways, apologies for the pause. We'll convert it to a 2 pointer and a 1 pointer decimal number. Okay, so first of all, 7.972. Let's write it down once again. We'll take 972 here. For one decimal point, that means 10th. We write the two sides, that is 970 and 980. By this time, it should be clear to you guys how to make the floor and seal part, the floor and seal numbers, how to generate those. The last digit we see is 2, so we put it to so we float it down, and we get 7. We get 7.97. This is the answer for one decimal point. Sorry, converting it to a two decimal point number. And if you are asking it me, okay, let me just write it down on this side, two decimal points. And the same thing, we're going to be scaling it down to one decimal point. That means nearest 100th. Last one was nearest 10th. This one is nearest 100th. Yeah. Check here. 972. These two digits 0 0 0 0. 9 stays as 9, and 9 becomes 10 on the other side. So where does this one go? Here is the tricky question. What do? We convert it to okay, so let me just go through the rules again. So it's 72 here, so it will be sealed up to 1000, but 1000 if, okay, I will be showing you guys both the scenarios. If I write 7.1000, is it correct? Like I can just simply neglect the points, like the zeros after the decimal points, right? So it is equivalent to 7.1, but the question was 7.972, and the answer even after sealing goes down to 7.1. What is it? Did I do the right thing? Of course not. I absolutely did not do the right thing. What you guys have to do here? You guys have to wait. Yeah, you guys have to take these three zeros, place them over here, and this one will be added with 7, and this 7 becomes now 8, and so what you get as the final answer is equal to 8. That's the right thing to do, because the last time it was pretty clear, I guess, to you guys as well, that how even after sealing the answer becomes 7.1. It was 7.9, so it should have gone higher, isn't it? That's what I told you guys while defining rounding off, isn't it? That's the thing. Okay, now let's go to 3 decimal point conversion. Okay, let me just write the heading: nearest 3 decimal point round off. Okay, how do we do this? There isn't any. Okay, no, my bad. This should have been nearest 4. Okay, nearest 4 decimal point round off. How do we do this? This is also known as nearest 10,000. Okay, why 4 decimal? Because there's 4 zeros, so it's obvious that this should be 4 decimal pointer. And as we do usually, we'll take some examples. Here we'll take the example of pi. Okay, because there's it's a recurring decimal, so there's no end. We'll take it up to let's say 7-8 points: 3.1415292. What am I doing? Yeah, 926. Okay. Suppose we are taking up to here. You're not going any further. Okay. We'll round it off to 4 decimal points. Okay, 4 decimal points means up to here. So up to here means this part is, sorry, 4 decimal point. Yeah, 4 decimal points means for nearest 1000, for nearest 10,000, start counting from the end. 1 2 3 4 5. what part do you get? It's 15926. So for nearest 10,000, you guys know what to do. We do this thing. We write at both the groups, that will be 15,000 and 16,000. Sorry, this should be nearest 1,000. I missed the trick. Yeah. So we have 15,000 on this side, 16,000 on this side. Now how do we do the thing? We consider the last three digits because we are doing 1000s. It's 926, so it will be sealed up to 16000. So in place of 15926 we write 16000. So the new decimal after rounding off we get as 1416000. We can simply omit the zeros, so it will become 3.1416. Similarly, we'll take another example, that is 37.35784. Suppose this is the example. Okay, let me just point it. Yeah, that was number one, this is number two. Okay, here this part will take, there's 5 digits here, so we don't need to worry at all. We'll scale it down to 4 digits. Okay, so let's just write it over here, 35784. Both sides will be 35770. 4 digit means, as we already know, only the last digit will be 0. That means 35770 and 35780. Check it out. 35784 and 35. Yeah. Now what to do? Where does this thing go? Okay, sorry. Oh, my bad. Yeah, exactly. This will be 35780 and this will be 35790. Now where do we go? The last digit we check, that is 4 will be flowed down, and the new decimal we'll get is 35780, and so the new decimal after formation becomes 37.3578. So we have 4 digits after the point, as you can see here. That's how we round off that's how we do nearest 4 decimal point round off. Now here's a miscellaneous thing. Okay, as you already know, if it's 0.5, which is exactly in the center of both sides, then there's a anonymous, like this is an anonymous rule. Okay, like there's no reasoning behind why this is implemented, but that's how we do it. Follow what I'm writing here. Any decimal number ending with 5 is sealed if the digit, or let's say the integer part, is odd. Sorry, if the integer part is even. If the integer part is odd, it remains as it is. Now where does this thing fall? This falls under the category of decimal to integer. Like suppose you are given a question that is 24.462. okay, how many digits are here? There's 3 digits here. So we'll have to convert it to either 24 or 25. Where does this go? We write 462 here. So to make it a decimal number, we have to make this part completely as 0. Okay, or we have to make this part 1000. So if it becomes 1000, that means it's the case of this thing right here. It's this one, this case. we just increment the first one with the integer number and it goes to the next integer number. Okay, 462 is what we have. So on either sides it will be like, so we have to, this is basically like rounding off to the nearest 1000. So 462 means we'll have to convert all these three digits to 0, and there's no digit before 4, so it will be 0. And on this side, since there's no digit before 0, that will be 0. So 0 plus 1 is 1000. So we have both the sides, floor and seal. Floor and seal. Where does this go? 462 falls in the category of 0 to 499 part. Remember, you guys cannot forget this grouping thing, okay? It falls here. So it will be flowed down. So we'll have 0, 0, 0, 0. That means 24.462 will be converted to 24.000, which is simply 24. If in this case it is 24.762, that means we'll do the same thing. 762 1000 000. We have 762, which falls into this category right here, as you can see, this one. So for 762 will be sealed and we will get 1000. So the new decimal from 24.762 will become 25.000. Why? Because we add this one with 24, we get 25, which is simply 25. This is decimal to integer, but here one thing is pretty clear, that the number, like the number in the decimal part, is greater than 0.5, which I wrote exactly over here, this one, which is greater than 0.5. 0.5 means 0.500. So it is sealed up to 25, and here it is 462. So 462 here, so it is sealed, so it is flowed down to simply 000. But what if it is 24.500? This is one example, and 23.500. This part is, as you can see, even. This part is, as you can see, odd. The decimal part is 0.5, and this is what you got to write. Decimal part is 0.5 and the number is even, so sealed. Here decimal part is 0.5 and the number is odd, so flowed. Got it? Let's just underline the crucial part. Decimal part is 0.5 and the number is odd, so flowed. They're even, so sealed, and it's 0.5. So what will we get? 24.5 will be written as 25 and 23.50 flowed, so 23 remains 23. Okay, cool. This is the part where students mostly get confused. I even used to get confused when I was a kid. Now I guess I managed to clear the doubt you guys might have had, but if you don't have a doubt, well and good. Anyways, that's it for rounding off decimals. Next video I'll be uploading will be on quadratic equations, and we'll be having some equations stuff videos coming out pretty soon, like quadratic equations, simultaneous equations, then equations where you have to make like subject of the formula stuff. These kind of videos will be coming out pretty soon, so make sure to subscribe to my channel